Okay, let's have a look at this frame here. So our goal here is to basically find all the reaction forces. Not just external reaction forces, but what's going on at C and what's going on at E and D. So first thing to start off with is to solve for our external reactions though. So I'll just draw a quick free body diagram of the structure. So we have that and we have a reaction. We're going to have a reaction at B. So B there is a roller, so it's only going to have, it's a roller against a vertical wall, so it's only going to be able to push away from the wall. So there isn't going to be any BY. We're also going to have an AX, and we're going to have an AY. So first things first, first of those that's fairly easy to solve for would be AY. So sum of the forces in the y is equal to 0. AY minus 480 newtons is equal to 0. Therefore, AY is equal to 480 newtons. Next off, let us go ahead and take a moment about point A. So if we're taking a moment about point A, we're rotating, pivoting about this point. The 480 Newton vertical load applied. That's going to be basically causing this thing to kind of want to rotate. That's going to be causing a clockwise rotation. So that's a negative moment. So taking the moment at A equal to 0, which is equal to negative 480 newtons times its horizontal offset times the 100 millimeters. And then we've got this force at B, so that would be causing a positive moment. So plus Bx times its offset, vertical offset, which is 160 millimeters. So from there, it's easy enough to solve for Bx is equal to that's Bx is equal to times 100 millimeters divided by 160 millimeters. So millimeters cancels out, and we are left with Bx is equal to 300 newtons. And then from there, simple enough, sum of the forces in the x direction is equal to 0. Therefore, Ax plus 300 newtons is equal to 0. Ax is equal to negative 300 newtons. So I'll just redraw that free body diagram real quick. Actually, you know what? I'm going to do this the lazy way. Newtons, 300 newtons, There we go. So there we go for our external ones. Now we also got our internal ones, right? So one thing, let's have a look at the that bar or link ACE. So we look just at ACE. It's 100 millimeters, 80 millimeters, and then from A to C, that'll be, let's see, 160 millimeters plus 60 millimeters, that's 220 millimeters. So what we do know is we know that there's going to be some sort of reaction force at C. So I'm going to have a CY, no, CX, that's a CX. I'm going to have a CY. We've got our 300 newtons, got our 480 newtons. And then we are going to have a reaction at E as well. EY and what am I trying to say? EX. Now, if we look at this, we know that ED here, that is a two-force member. So we know that it is either going to be in compression or tension. So what we can do is we can figure out what the ratio is between our EX and our EY. So we just have to basically find out what the unit vectors are. So our distance, ED, it's equal to the square root of 150 millimeters squared plus 80 millimeters squared. It's 170. So, let's call the force in that bar or that link FED. So then we know that our EX is equal to 150 millimeters over 170 millimeters FED, and then EY is equal to 80 millimeters over 170 millimeters FED. So let's see, EX (0.8824) FED, and EY is equal to 0.4706 FED. So I'm just going to take that EY and plug it in. solving for FED in terms of EY. One over that gives us 2.125 EY. So then I can just plug this into here. So EX is equal to 0.8824 times 2.125 EY. 75 EY. So that's how we relate those two things. So what we can do here is we can go ahead and take a moment. So essentially, if we take a moment about C, then we'll have the two unknowns EX and EY, but those will be related to one another. So sum of the moment about C. So looking at our forces here, obviously, so the 480 Newton force, its line of action passes through C, so it doesn't contribute to any moment, as it does CY and CX, obviously. So the components that we do have are going to be the 300, which is going to be causing a positive, and EY and EX, which are both, based upon their orientation and location, going to be causing a positive moment about CY. So let's see, it's 300 newtons times 220 millimeters. And plus, let's see, so EY times its horizontal offset, which is 100 millimeters. I'm going to plug in the, EY. I'll keep it in EY. EY times 100 millimeters. And the EX component, except instead of EX, I'm going to plug in what I had here. So 1.875 EY. And then times the horizontal component of the offset there, which is 80 millimeters. All that stuff's equal to 0. So let's see here. 100 plus 1.875 times 80. So that'll be 250 millimeters EY plus 66,000 Newton millimeters is equal to 0. So solving for EY, EY is equal to negative 264 newtons. As a result, EX is equal to that times 1.875 negative 495 newtons. Okay, so what that means, EX, like the EX and EY, those are pushing on the link ACE from that side. They're not pulling, so it's a compressive force within the member ED. So we'll draw the next link here. So if it's compressive, then that means over on the bar BCD, then we've got a compressive force that is pushing this way at dx, and pushing upwards here, 264 newtons. And we already knew that this force here is 300 newtons. And we've got the external load, the 480 newtons. And then we've got our two unknowns. We've got Cx and Cy. Now again, just keeping in mind that when I originally defined Cx and Cy on this diagram, Cx is pushing in the positive x direction on bar ACE, and Cy is pushing upwards in the y direction on bar ACE. So on BCD, we need to do the opposite to be consistent. So here, define this Cx and Cy. So simple enough to solve for though. So again, let's start with sum of the forces in the x direction is equal to 0. 0 is equal to 300 newtons plus 495 newtons minus Cx. Therefore, Cx is equal to, what's Cx equal to? Why did I bust out a calculator for that? 795 newtons. Cy. Well, sum of the forces in the y direction is equal to 0. Therefore, 0 is equal to 264 newtons minus 480 newtons minus Cy. So we can solve for Cy, add it to the other side. Cy is equal to 264 minus 480 newtons, 264 newtons minus 480 newtons. So Cy is equal to negative 216. So we'll just kind of, I'll just go ahead and kind of fix the sign there. So that means that on BCD, Cy is actually pushing upwards. 216 newtons. And then on BCD, Cx is 295 newtons. And then basically going over to ACE, the opposite happens. So at C, so on bar ACE, we've got this downwards force of 216 newtons, and the positive force in the x direction of the 795. And then we've got our AY. So AY was a positive 480 newtons, and it was a negative 300 newtons. And then we've got the effects of the compression in link DE. So let's see, what was the magnitude of that? That was 264 for the vertical, and the horizontal component was 495. And yeah, it looks to me like everything balances there, so we're good to go. So that is what's going on with all those forces in that link.